Hey, Steve.
Hey, Paul, how's it going?
Very well. So, Steve, I brought you in because we're looking at putting in a new product line, and I'm in charge of actually putting together the cost for the project so we can actually set our budget.
Oh, a new product line. That sounds exciting. Are you going to be building onto your facility or remodeling or a new portion of it?
Actually, we have capacity here in the north building, so we'll be putting it in here.
Oh. Do you have a drawing of the layout or any specifications that you might need?
Absolutely. I actually have it right here.
Let's take a look at it, see what you need.
Okay, so this is the actual line and area we're going to be installing, so everything highlighted here in yellow.
Okay.
This is the revised proposed concept.
All right, so you get a nice through the starting point and then the ending point. It's nice to go over the layout with you. Sometimes I don't get that, but if you'd like, why don't we go out and take a look on the floor there and see that area and the elevation change that you're talking about?
Absolutely. I think we'll take you out over on one of our current production lines.
Sounds good.
Okay.
Hey, Nick.
How you doing?
All right, how's it going?
Great, thanks.
I'm working on some conveyor for rockline.
Okay.
And I need, in one section of the conveyor, for it to change elevation. So I need to order friction top belting to make sure the product doesn't slip back down. So I was wondering if you could help me figure out how much conveyor belt to order.
You came to the right place, Tim. Let's start by plotting out the conveyor. So for this, we're going to designate one corner of the room as the origin. So we're going to have x equals 0, y equals 0, and z equals 0.
Okay, the conveyor actually needs to start 4 feet north of the wall and 5 feet east of the wall, and right there the elevation is going to be 3 feet.
Great, so that means x equals 4, y equals 5, and then z equals 3. What is the end point?
The conveyor is going to end 10 feet north of the wall, 22 feet east of the wall, and there the elevation is going to be 8 feet.
Sounds good. So we got x equals 10, y equals 22, and z equals 8. Now, because the conveyor forms the hypotenuse of a right triangle with the floor, we can use this to determine the length of the conveyor. Here's a 3D graphic with the coordinates. Alright, Tim, now using the distance formula to find the length of the base, we came up with 18.027 feet. Now, how can we use the length of the base to find the hypotenuse?
Then we use the Pythagorean Theorem to figure out the length of the hypotenuse. The length of the hypotenuse is 18.7 feet, so I need to order 37.4 feet of conveyor belt.
Why do you think we had to double it?